Okay, we have a Nintendo Switch. They claim no power. It's seen better days. It's not in the best physical condition. They don't know if it's a port or what, so let's take a look. Well, the port is definitely not great. There is one bent pin in there. Let's see if I can get that on screen. Yep, one bent pin. So, same routine. We will disassemble. We will take the board out. We will remove the port, and then we'll do measurements to see if there was any collateral damage. I don't see. I guess it is making contact with one pin, so there's a possibility it did some collateral damage, but we won't know until we remove the port. Anyway, we'll be right back. Okay, we're back, and we're prepping for port removal. We will start with our pins. We will do it as we always do it. Flood with low melt. Make sure I have the right ones hooked up. I need the 120 for wicking. And that's the tweezers. I don't want the tweezers. I just ordered a new base station so that I don't have to swap irons anymore. It was fine when I only had 2 irons, but now I have 4. Let's get that charger out of the way. Grab our micro pencil. So soon I will have the micro pencil and the 120 watt on their own, and then I'll have the pico pencil and the micro tweezers on their own, and I won't have to swap anymore. At least till Weller decides to come out with another iron I must have. Cannot foresee that happening, but never say never. Alright. Just need enough on there to flood these pins. Preferably not everywhere else but the pins. There we go. Make sure they're well flooded. The only thing I want to worry about when I'm pulling are the hidden row of pins. Alright, flip over. And I think we will go this way with it. We acquire. And get focused. And come out a bit. Let's apply some more flux. See if I can actually grab the low melt this time. Give me a big old bead on here. There we go. Saturate these anchors as well as we can. Come on up. There you go. And just suck that right in there, please. Very good. Alright, and we'll clean off. So we do not need to be burning that burned up flux anymore. Get most of the pulled stuff first. Because we also don't need to be spreading it all over the board. Preferably. Let's see. Alright, good enough. Now, get situated. We'll grab our ceramics and our bigger glove, or thicker glove. I think we're about ready. Our temperature is right, airflow is right, correct nozzle. Oh, did not put any more flux on. Just make sure I'm not going to be in a position where I'm hitting the camera. Even though it's not the main camera, it still would be annoying. Okay, concentrate on these outside anchors first, so the other ones could start flowing too. They already have. Good. All right, now we'll start working on the hidden row and doing some strategic nudging. Nothing too difficult, nothing too hard. We're not trying to force it off, we just kind of want it to fall off. There we go, like so. Now, it doesn't mean there isn't a pulled pin or a pulled pad. We won't know that until we look at our port. Okay, I don't see any pulled pads on there. How's that look to you guys? Looks pretty good. So I think we're probably okay. That's probably a good pull. One way to find out. We'll flip it over, take a look. Looks good. Yeah, I just want to make sure there's no bridging. Alright, there's no bridging, so I'm going to flip the board on the holder just to make it easier to work on for the port placement. I love this board holder compared to, well, for the Nintendo Switch, and I did a iPad port with it recently too. Guess I better make sure it's not a client trying to get a hold of me. It does not appear so. All right, I'm going to clean that up just a little bit because I'm already here with the dang brush, so might as well do it. Just to double check, make sure none of those pins are bridged, and then we're going to do some measurements. Good enough. Wasn't necessary to do measurements, but for some reason I decided I needed to clean first. And as always, let's pull our additional light over here so you can see part numbers, hopefully. At least to a degree. Well, as always, we're going to start over here at the M92T36. Make sure the meter is connected. All right. And let's measure red on ground. Okay. This one is is connected to P13 USB. If P13 USB is bad, usually this will be an indicator. We seem to be okay there. Alright, so these are the signal lines for M92T36. So really you only have to measure these. I sometimes measure them both, but... Alright, it looks like we lost M92T36. These should not be shorted on this side. They should be only reading to ground on this side. So these are shorted, and this one's shorted. That's also a signal line. So all three of these guys right here are shorted. That means that's bad or worse. Okay, let's check our... Okay, everything else seems okay over in here. Let's check around our MOSFETs. Make sure we're in view. Seem okay. No shorts. Check our little filter. Okay. As usual, our fuse did not do its job. It's still good. This fuse for the Nintendo Switch is like the backlight fuse on a MacBook. Filter is good. Not short of the ground. Check our BQ24193 area. Okay, seems okay over here. So we definitely have an M92T36 problem. Well, not definitely. We have a problem in the area. And what we need to do is pull it and make sure that those shorts are relieved. If they're not relieved, we have a much more severe problem. Let me straighten out my solder first. I have a severe problem with my solder. It's gotten wrapped up in my microscope and spin around the microscope and make everybody throw up. All right. All right. So let's remove that extra light. Will not be needing it for the moment. Okay, so let's remove this M92T36. Because he is no good. I don't know if any of the batch I got recently in are good. I definitely had one that was bad. I don't know if that video will get posted before this one. We'll see. I don't always do these things in order. On a whim, what do I want to post this week? As always, when pulling these, be patient. This board can take a lot of heat. It absorbs a lot of heat, dissipates a lot of heat. So just wait until you see wetting all the way around. And pull. Alright, well, let's check and make sure our shorts cleared. If they did not, there is no point in proceeding with this situation, probably. It's very unlikely the caps are shorted by themselves, but we can check that if that's the case. Right. Reverse our... Alright, so these are the signal lines. Clear, clear, and clear. So it appears that removing M92T36 removed our short. That's good news. Unlike some electronics, Nintendo Switch doesn't have a high capacitor failure rate, at least as of yet. It's almost always going to be logic on these if you're finding shorts. And you got to be careful about finding shorts like in this area. This is CPU. It's a low resistance line. So if you're finding shorts in there, it's because you're in continuity, and continuity is not meant for that type of resistance. Same thing with the max chip. This is a low resistance line. You're going to find shorts in there. Same thing over here. Low resistance line. You're going to find what appears to be shorts here, but they're not short. Okay. Let's do some cleanup. So I'm going to come at it this way, in the vain hope that I am not going to short things around the chip this time, or bridge things around the chip this time. And we are going to flood with leaded solder so that it will make wicking the solder up easier. In theory. In fact, really. But by mixing leaded solder with the unleaded solder, you are reducing the melting temperature of the solder. I don't care about bridges right now. It's all getting wicked up. Okay, now I'm going to clean off some of this old flux. Let's wick up some of that flux first. Don't care about how big a mess it's making. It will soon be cleaned off. in this direction so as to not spread all the way up the board. Don't care if it gets on my mat, we clean that after every repair. I will not blow in your ear. I wanted to. Alright, now we'll apply some fresh flux. A generous amount. And we will wick. Let's find our wick. Try to trim that up and use a little bit more of it. We're quickly running out of it on this one. Turn the bush. Throw the air. Grab the air. Alright, let's clean up. Yeah, got a little rough on that one. But we did not pull it. Oops. It does like to get stuck on that center pad sometimes. Okay. It's alright. Let's wick some of that up. Scrub it up. We'll take a look at that one pad. Make sure we don't have anything catastrophic going on. I'm using a brush, I'm not scrubbing hard. Just lightly raking it over it, pretty much. Alright, grab my fine tip. That pad took a little damage there. Think it's salvageable. Alright. We'll find out when we tin. If it gets sucked up with the tinning, then we may have to address it. Not too much, half the pad will be left, but see, Jason, even the seasoned guys do it. Alright. That was totally a wicking incident there. I was going against the pads instead of just tapping them like I should have. On the Nintendo Switch, you generally just want to go with the pads or just, tap lightly on top of them. You don't want to wick across them. Can result in bad things. Seems to be okay. Alright. I think we'll be okay there. No bridges. Good. Let's wick up the excess solder. I mean excess flux. Blah, blah, blah. Grab a brush, clean it up real good, or clean it up reasonably good. Alright, think we're reasonably prepared for placement. Cross our fingers that we do not get a second bad chip out of this batch. I think I only have one left from my prior batch, which was all good. And my recent order from another vendor has still not come in yet, because I ordered a backup batch after the first one of these was bad, so, and it was 100% bad. Alright, so orientation. That little arrow right there is pin 1. That little dot on the chip is pin 1. And for this part, we're just looking to tack it down. Part of the procedure, rather. And for this, we will come in with low airflow, or lower airflow, same heat. And all we want is some of the pins to wet and grab the chip. Not looking to flow the whole thing here. Yeah, our alignment doesn't look too good. Let's make sure our alignment looks reasonable, because that's what we're going to be working from. I'll check that. It's okay. It's okay. Okay. Now we'll do it. Now we'll try and tack it down. And this requires just a little bit of patience. Don't need all the pins to wet, just some of them. Enough to hold our guy in place. See how we did? I think we did. All right. See if it moves. It does. Ooh, it does move. Damn it. That was not what I wanted to happen. We almost had it right. Just didn't give it time to grab on. Shouldn't take long this time. We were wetting as it was. Alright, wetted, 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 wetted. Alright, that should be good. Let's add some flux. And bring the sauce. Now we want a complete reflow, and we'll press it down on the board. Oh no, we did not want it to go flying off anywhere. Why are you doing that? Jesus. Yikes. That was not what we wanted to happen. Turn that airflow back down. See if we can get it to tack down again here. I don't know why it's not tacking down. Jesus Louise. This is why I don't like flux for this part. Okay. Let's bring the sauce. All right. Looks a little crooked. All right. That should be good. We're recording, so let's have a problem. Or let's have problems. Do a million of these and not have a problem, but I turn on the camera and have a problem. Alright, let's make sure we didn't nudge anything or bridge anything in our float away adventure. Let's wake up some of this. Excess. And we'll inspect after we get it cleaned up here. I think there might have been a little too much on the center pad for me, for my typical method. Let's see, do I have any clean wipes? I think my brush is getting a little saturated. All right. Can tell by the residue it's leaving behind. Does not typically do that if it is not saturated in flux. There we go. That's better. All right, let's inspect our work. Slightly off kilter there. Making connection, but slightly off kilter. That's way too off kilter. We're going to have to fix that, unfortunately. This one's going to be a problematic one. So we need to come down and over a bit, just a bit. Pull into place, that'd be nice. Down. Oop, over too much. That burned the hand. Alright, let's see if we did any better. Didn't like all the movement there at the end. So we may have ended up with the same results, just in a different direction. We'll see though. Hopefully this is not going to be a five-time trial type thing. Like, when you're not sure about the chips and then you're having to do it put heat on it 5 times. That's not a great test. It's not answering the question, did you get a bad batch? Alright, let's look. Still off kilter, but it's connecting. Didn't end up in the same damn place, did we? Sure as hell did. What in the hell? Ended up right back where we started. The odds of that are pretty freaking astronomical. You can stop screwing around anytime now. Isn't planning to spend all night putting on an M9 chip. Alright, take a look before we even clean the flux off. That's better. That's better. Not perfect, but it looks like they're connecting. That's better. Really hard to see this one. That's straight on those. Pretty much. Alright, I think that'll work. Good grief. Been watching too many of Jason's videos. I'm just kidding, Jason. you haven't subscribed to Engineering Scale Models, it's one of my featured channels. If you look on my page, on my YouTube page, you should. He's learning how to do these, but he's also an engineer, so I think he's going to be very valuable to the community. For some of the other projects he's doing regarding the switch. Alright, let's inspect again. Those look good. Those look good. Those look good. So, on QFMs, the markings on the side are not pins. They're just alignment markings. You don't need solder going up all the way onto the side of the pins. Yeah, it looks good and everything, but they're just there for alignment. Alright, looks good. Now whether the chip's any good, or if it ever was any good, we will only find out once we get done this part. See if we can do this without annoyances. All right. Alright, I think this wick has been thoroughly used. We need a new hank. Not the small stuff. Not the huge stuff. All right, let's continue with a nice new fresh wick. All right, good start. And that one I'm probably going to have to hit from the other side. Alright, so with great care, just slightly glide over these pads. Like a skate on ice. No more pressure is needed. Like so. Alright, so let's hit that other anchor over here. See if we can get the rest of that solder out of there. Flip our wick around. Go ahead and get those test pads. I think we got a little mud on them. Might as well leave any of that on the board. We can get the rest of that maybe with our micro pencil. Good enough. Alright, let's clean up. Alright, flip it over, clean up some more, make sure I still have audio. I've been having a little bit of issues with the batteries. I got a false charge on a couple and it screwed up at least one video and the end of another. All right. We can remove our liquid indicator. I don't think it has relevance at this point. All right, let's clean our micro pencil real good. Nice puffy pillows. All right. Now we need a port. Put the board aside. We'll grab our board holder. Other board holder. I like it for doing ports in. Grab a fresh new port. I'll be forced to do another port order soon. Going through them like crazy. All right. Why aren't we stuck together? All right. And we will tin our port. My hand isn't shaking, it's just I'm trying to one-hand the flux. Grab, apply some heat to that flux real quick, maybe. like a painter paints. I shall paint those pins. Silver. Chrome. Alright, looks pretty good. Grab our board again. And we'll flop our connector on there. Get us back in view here. Alright. You can see the pins real well. Set everything aside that does not need to be in my way. And we will be nice and prepped. Place the port. Warm up the wrist. Rapid air movement. What I'm really saying is we want rapid nozzle movement here. The idea is to make the board hot enough to wet the solder, but not have the heat in any one place long enough to melt plastic. That's the goal. Hand off before I burn it. Don't need it being burned right now. Alright, we're getting wetting on the outer pins. We'll go a little longer and make sure we're getting the inner pins. And we'll press down, remove the air, hold it down while it's drying. Like so. I think that was a good placement, but we'll find out shortly. And how I find out is I just kind of, and this is a feel thing, so you'll have to do a few to get the feel, but I just kind of test it. And you can tell if you only get one row, the outer row of pins, it'll feel kind of loosey-goosey. But here it feels real solid, so I think we did fine. Flip the board over and we'll get these anchors. Get in a direction we can work. Add some fresh flux. That won't want to glob on there because it's still quite warm. All right. Grab a hank of solder. See how we have a few sitting laying around. And grab our iron. Give it a nice cleaning. Throw a little solder on there. Not reset. It's plenty. Just flip it around. Get it back in view. These other anchors. Sure that's not in view for you very well. That one's not in view for you at all because I'm not on the right scene. The meters at the moment. And I'm not got enough there to feed. Okay. I'm going to clean the iron because I feel like that black gunk's going to get all over the place. Get this last one. It's probably good. Yeah, that's probably good. One way to find out after we're done cleaning up here. We might as well while we're here. So some of that pulled up stuff up first. Just so we don't spread it further than it needs to be. Okay. I'm going to hit the inside a little bit because I'm sure it got a little fluxed in there. And we'll hit this other side a bit while the inside is drying. Get the gunk off from the no longer needed water indicator. Let's get it all cleaned up here. And dry it up so we can do some testing. See if we have another bad chip. Sure we're not wet or dumped up in there anymore. We'll give it a little better cleaning before we stick it back in its housing, but let's do a quick test, shall we? See if we're getting normal behavior or any behavior. We are on, yes. Let's see. Okay, that looks pretty good. Oh, y'all need to be able to see it. Sorry. I guess we could just switch to bench, but yeah. So that looks like normal behavior. I'll unplug. Try the other side. Okay, that looks pretty normal. That's a good sign. We're getting power on both sides. All right, so I'm going to clean it up a little bit better off camera so I can use my air compressor, and then we'll be back once I have it in the housing enough to test. Okay, we're back. We have assembled enough to test. I've grabbed my known good battery. My known charged battery. I don't know that theirs is bad. It's good to have a charged battery laying around to test with. And we'll grab our PSU and see what happens. Okay. Got a half full battery. See if we boot up without error. You're not seeing any of this. Sorry. Alright, looks good. Let's make sure we're charging both sides. Oh yeah, 1.43 amps. That is fast charging. So, good. Everything looks good so far. We'll reassemble. I'll let it charge for a while, and then we'll come back and run some tests. Alright? Be right back. Okay, we're back. We're up to about 25%. That's good. For the moment. Pull our dock over. See if I can arrange this where you can see it. And put our dock charger in. Stock charger. And we'll plug our guy in here. Make sure we're getting dock sync. Okay, we're getting the green light. See if I can arrange this so you can see the dang green light. There we go. And let's see if we're getting, ta-da, new toy. That's our new HDMI capture device. It is capturing and syncing fine, and this is on the OEM dock. So I believe our repair is finished. I appreciate you watching. Like and subscribe, and see you next time.